parallel resonance. The parallel resonance, it is also called as an anti-resonance. Parallel resonance. Okay. This resonance, it is also called as an anti-resonance. Anti-resonance. So a parallel AC circuit is to be resonance. And what condition means? When it is susceptance is zero. At parallel resonance, the applied voltage and the resulting current will be in phase, as a result of which power factor will be unity. A parallel AC circuit is resonance when its susceptance is zero. At parallel resonance, the applied voltage and the resulting current will be in phase, as a result of which power factor will be unity. We'll derive the expression for general parallel RLC circuit. General parallel RLC circuit. So this is the circuit, general parallel RLC circuit. It contains a resistance and then inductance, and in parallel with the resistance, and then it is a capacitance. So here it is connected to some voltage source. This is where voltage source it is connected. Okay, and this is the current. I is the total current, and it is a branch current IL, and another branch current is IC, and this resistance it is called as a RL, and this is the inductance. This is our RC, and this is the capacitance. Here RL and RC respectively they called as a ohmic resistance of the inductance. RL is called as a ohmic resistance of the inductance, and the leakage plus the dielectric loss resistance of the capacitance. That means RL is the ohmic resistance of the inductance. RC is the leakage plus dielectric loss of the loss resistance of the capacitor. But these resistances are generally small. Therefore, admittance YL, what is the admittance YL of branch containing inductance? What it contains now in the branch? It contains the inductance now here, containing inductance L, containing inductance L, and resistance RL. So therefore, admittance YL is given by 1 by ZL. What is the total admittance in the branch RL and L? That is given by 1 by RL plus JXL. We are calculating admittance of the branch containing resistance and inductance. What is the relations between admittance and inductance? Admittance and impedance, that is YL is equal to 1 by ZL. So 1 by, what is the total impedance in that branch? RL plus JXL. This you have to rationalize this term. Rationalize means you have to RL minus JXL divided by RL plus JXL into RL minus JXL. Now further you simplify this. This is RL minus JXL divided by, this is in the form of A plus B into A minus B. What is the A plus B into A minus B? That is nothing but A square minus B square. Here A square is RL square minus B square. That is XL square. Okay. But J into J square. J square is minus 1. Therefore, this becomes plus RL square plus XL square. Now admittance YC of the branch containing resistance and capacitance. Calculate. So admittance YC of branch containing, what it containing that branch? Containing capacitance, okay, capacitance and resistance RC, okay. So therefore Y of C is equal to 1 by ZC, right? What is the ZC here? Total impedance in that branch containing resistance and capacitance. What is the total impedance? RC minus JXC. Rationalize this term. That is RC plus JXC divided by RC minus JXC into RC plus JXC. You simplify this. This is nothing but RC plus JXC divided by, again this is in the form of A plus B into A minus B, that is A square minus B square. What is the A square here? A square is RC square minus B square JXC whole square. Okay, J square is a minus 1, minus that becomes a plus minus into minus plus, and this is where XC square. RC YC is equal to RC plus JXC divided by RC square plus XC square. Next, what is the total admittance now? So what is the total admittance? Total admittance that you can represent it as a Y of T. What is a Y of T now? Y of T is nothing but sum of these two. That is admittance at the inductive branch plus admittance at the capacitive branch. Okay. So this is nothing but RL minus JXL divided by RL square plus XL square plus RC plus JXC divided by RC square plus XC square. So that is equal to, separate real and imaginary part. Then we can write it as RL divided by RL square plus XL square plus RC divided by RC square plus XC square plus J into XC divided by RC square plus XC square minus XL divided by RL square plus XL square. Okay, this call this equation as a 1. In parallel resonance, what is the condition in parallel resonance? Susceptance is 0. What is the susceptance here? Which term is a susceptance? This branch is a susceptance. So this term is a susceptance. Okay. In parallel resonance, susceptance is 0. Therefore, you equate that susceptance as a 0. That is, complex admittance will be a real number. So therefore, susceptance is 0 means what is the term susceptance? Xc divided by Rc square plus Xc square minus XL divided by RL square plus XL square, that is equal to 0. Because at parallel resonance, the susceptance is 0. So therefore, we can write like this: Xc divided by Rc square plus Xc square minus XL divided by RL square plus XL square is equal to 0. So this you can write it as like this: Xc divided by Rc square plus Xc square is equal to XL divided by RL square plus XL square. Xc is 1 over omega naught C divided by RC square plus Xc square is 1 by omega naught square C square is equal to omega naught L divided by RL square plus XL square is omega naught square L square. Further, you simplify this. This we can write it as 1 over omega naught C multiplied with this RC square plus 1 over omega naught square C square, that is equal to omega naught L divided by RL square plus omega naught square L square. Okay. You multiply this, cross multiply, then we'll get RL square plus omega naught square L square is equal to omega naught square LC into RC square plus 1 by omega naught square C square. Okay. Next, further you simplify, that is RL square plus omega naught square L square is equal to omega naught square LC RC square plus, so omega naught square cancel, we'll get L by C. L by C. Because we want to calculate a F naught, therefore you take the omega naught square left hand side. So we can write like this: omega naught square L square minus omega naught square LC RC square is equal to L by C minus RL square. So this we can write again. Here you can take this omega naught square as a common factor. Omega naught square is a common factor. Omega naught square LC you take the common factor. So omega naught square LC you take the common factor. So omega naught square LC is a common factor. Then you will get here in the first term we'll get L by C. Next we'll get here RC square that is equal to L by C minus RL square. So then omega naught square, you take the omega naught square is equal to L by C minus RL square divided by L by C minus RC square. So then you can take this omega naught, that is equal to square root of L by C minus RL square divided by L by C minus RC square. Next, what is the F naught now here? Because omega naught is nothing but a 2 pi F naught now. Then F naught is equal to 1 by 2 pi square root of, this I will interchange RL square minus L by C divided by RC square minus L by C. So this is the derivation. So omega naught square here, no, here it will comes 1 by LC. I forgotten to write here 1 by LC into this, and here 1 by LC 1 by root LC here, 1 by root LC into square root of RL square minus here 1 by 2 pi root LC. Here this is 1 by 2 pi root LC, 1 by 2 pi root LC. That is F naught is equal to 1 by 2 pi root LC into square root of RL square minus L by C divided by RC square minus L by C. So this is the derivation. In the exam they'll be asking like this question: show that a two branch parallel resonant circuit is resonant at all the frequency if RL is equal to RC is equal to root of L by C, where RL is equal to resistance in the inductor branch, RC is equal to resistor in the capacitor branch. When you ask a question like this, you have to derive up to this point, that is F naught is equal to 1 by 2 for root LC square root of RL square minus L by C divided by RC square minus L by C. They can ask in the exam for 8 or 10 marks. Previous examination, they'll ask this question for 8 marks. Is it clear? Any doubts? Diploma student, if you have any doubts, you can ask me, I will explain. Hello.
Yes, sir.
ಏನು ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳ್ರಿಪ್ಪ ಇಲ್ಲಿ. ಹಾ ಹೇಳಿ. ಏನೇ ಡೌಟ್ಸ್ ಇದ್ರೆ ಹೇಳಿ.
ನೋ ಡೌಟ್ ಸರ್.
ಅರ್ಥ ಆಯ್ತಾ ಡೈರವೇಶನ್?
ನೋ ಸರ್.
ಅಥವಾ ಇನ್ನೊಂದ್ಸರಿ ಹೇಳ್ಬೇಕಾ?
ಎಸ್ ಸರ್.
ಇನ್ನೊಂದ್ಸರಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಲಾ? ಓಕೆ, ಇನ್ನು ನೋಡಿ ಹೇಳ್ತಾ ಹೋಗ್ತೀನಿ.
ಎಸ್ ಸರ್.
ನೋಡಿ, okay, this is a parallel resonance. In the parallel resonance there will be two circuits. One is called as a general parallel RLC circuit, other one is called as a practical RLC circuit. They can ask the derivation and they can ask a problem also. Okay, two derivations you have to practice. In parallel resonance the susceptance will be 0. Okay, and the current at resonance, the current will be in phase with the applied voltage. First we'll consider a general parallel RLC circuit. General parallel RLC circuit consists of a RL resistance in series with the inductance. Again in parallel with the RC resistance in series with the capacitance. RL is called as a dielectric loss resistance and RC is called as a leakage resistance. But these resistance are generally small. You have to calculate what is the admittance of this each branch. What is the relations between admittance and impedance? Impedance we are representing as a Z, admittance we are representing as a Y. So admittance of the branch that contain the element RL and L, that is given by 1 by ZL. That's why I written OL is equal to 1 by ZL. Z is nothing but a total impedance. What is the total impedance here? If you two RL and L is there, no, therefore it is RL. L we are representing in the form of no JXL. That is RL plus JXL. So 1 by ZL is equal to 1 by RL plus JXL. This you have to rationalize. Rationalize means if it is already positive is there, no, you have to multiply and divide by negative. That is RL minus JXL. If you RL minus numerator and denominator, if you cancel, no, you'll get a same value only. That is called as a rationalization. So you rationalize this term. That is, you have to multiply it and divide it with the RL minus JXL. Opposite of that, what is there, no, present. RL minus JXL in the denominator, it becomes A plus B into A minus B. You know the formula. What is the A plus B into A minus B? That is equal to A square minus B square. Here A is RL, B is nothing but a JXL. A square means RL square, okay, minus B square, J square XL square. But J square is a minus 1. Minus into minus, that is plus. Therefore, in the denominator, we are getting RL square plus XL square. That is actually A square minus B square. A square is RL square minus of JXL square. But J square is a minus 1, minus into minus plus. Therefore, RL square plus XL square. Similarly, find out what is the admittance YC of the branch containing the capacitor and the resistance RC. So here YC is equal to 1 over ZC. So what is the total admittance in that branch is 1 by RC minus JXC. RC minus JXC. Again here also you have to rationalize this term. Because here minus is there, no, therefore you have to write RC plus JXC. That is a rationalized term, numerator and denominator. Now RC plus JXC in the denominator, RC minus JXC into RC plus JXC. Again, this is term A plus B into A minus B. That is A square minus B square only here also. That is RC plus JXC divided by A square is RC square minus JXC whole square. Again, J square is a minus 1, minus into minus plus, therefore plus XC square. Then the total admittance Y of T is given by YT is equal to YL plus YC. Add these two, RL minus JXL divided by RL square plus X square plus RC plus JXC divided by RC square plus X square. Now, separate real and imaginary part. Rewrite the above expression. That means separate and real and imaginary part. The first term it contains the real part. That is real part is RL divided by RL square plus XL square plus RC divided by RC square plus X square plus J. Imaginary part terms. What is the imaginary? J XC divided by RC square plus X square. In that take the J common factor. Again other one term is minus JXL divided by RL square plus X square. So therefore we can write plus J into XC divided by RC square plus X square minus XL divided by RL square plus XL square. That is this Y of total admittance, it contains a real part and a imaginary part. In the parallel resonance, susceptance is 0. What is the susceptance here term? Susceptance is the term is here in this equation XC divided by RC square plus X square minus XL divided by RL square plus X square. That make it as a 0 because according to parallel resonance, susceptance is 0. That's why we're equating this as a 0. Again this term now you can write it as, you can take this as a right side, then we can write XC divided by RC square plus X square is equal to XL divided by RL square plus X square XL square. XC is nothing but 1 over omega naught C, XL is nothing but omega naught L. That you substitute in the these two equations. Further you simplify. Further, you can simplify 1 by omega naught square into RC square plus 1 by omega naught square C square is equal to omega naught L divided by RL square plus omega naught square L square. This you cross multiply. Now here you are multiplying this RL square plus omega naught L square is equal to, this is omega naught square LC into RC square plus 1 by omega naught square C square. So now further you simplify RL square plus omega naught L square. This is omega naught square LC RC square plus here omega naught square cancel. C will cancel. Left out is only L by C. So because we want to calculate F naught, therefore whatever it contains omega naught term that you transfer to one side. That then this becomes omega naught square L square minus omega naught square LC RC square is equal to right hand side L by C minus RL square. So omega naught square LC, as I take the common factor here, then you will, in the first term it will be left out is L by C here minus RC square, that is equal to right hand side L by C minus RL square. Then omega naught square is equal to 1 by LC into L by C minus RL square divided by L by C minus RC square. Then omega naught is equal to 1 by root LC square root of this. But omega naught, as we know that omega naught is a 2 pi F naught, therefore F naught is equal to 1 by 2 pi root LC square root of RL square minus L by C divided by RC square minus L by C. So then admittance at resonance. So admittance at resonance is given by this formula. Admittance at resonance is given by Y naught is equal to this term, real term. What is the real term here? No. So real term in this, real term is RL divided by RL square plus XL square plus RC divided by RC square plus X square. That is the admittance that you are right. Y naught is equal to, so Y naught is equal to RL, okay, RL divided by RL square plus XL square plus RC divided by RC square plus XC square. And current at resonance and current at resonance and current at resonance, and current at resonance will be, that is I is given by I is equal to Y naught into V. So that is equal to V into RL divided by RL square plus XL square plus RC divided by RC square plus XC square. So based on this, we solve the one problem. Note on the problem. Find the value of R1. Find the value of R1 such that find the value of R1 such that the circuit shown in figure is resonant. Find the value of R1 such that circuit shown in figure is resonant. So this is the question here. The circuit is this. It contains a one resistance and then it is a inductance. Again here, this is the resistance and it contains the capacitance. So here there will be a voltage. So this is your R1, and this is J6 ohm, and this is your 10 ohm minus J4 ohm. So in this circuit, to find out what is the value of R1. Find out. So as we know that near, what is the ZL now? YL now here. YL is equal to 1 by R1 plus J6. This you have to rationalize. That is R1 minus J6 divided by R1 plus J6 into R1 minus J6. Simplify this. Okay. Rationalize now here. Simplify this. So this is equal to,
R1 minus J6 by R1
uh,
square plus J6 square.
this is J6 square. Andre ಏನಾಯ್ತು 36 R1 square minus J6 square. J square is minus what? Minus plus 36. R1 square plus 36. This is your YL. Then what is a yc? Yc is equal to 1 by 10 minus j4. 10 minus j4. That is equal to again 10 plus j4 into 10 minus j4 into 10 plus j4. So this is equal to 10 plus j4 divided by this is 100 plus how much? 16. Okay. 10 plus j4 divided by 16. Then what is the total admittance? Y of t is equal to how much? YL plus YC. YL is nothing but R1 minus J6 divided by R1 square plus 36. What is the YC? YC is nothing but 10 plus J4 divided by 116. Separate real and imaginary part. Real part is R1 divided by R1 square plus 36 plus here 10 by 116 plus J into 4 divided by 116 minus 6 divided by R1 square plus 36. Okay. Separate real and imaginary part. Now, according to parallel resonance, susceptance is 0. Susceptance means this is the susceptance. This term is 0. Okay. This term is 0. Make it the term is 0. That is 4 by 116 minus 6 divided by R1 square plus 36. That is equal to 0. That is 4 by 116 is equal to 6 by R1 square plus 36. Further you can simplify. This is 2 2s and this is a 3. Next, how much it is? Further you simplify this. So this we can get it a 2 into R1 square plus 36 is equal to 116 into 3, or R1 square plus 36 is equal to 116 to 3 divided by 2. How much it is?
174.
174. Okay. This is 174. Further you simplify again. So R1 square is equal to 174 minus 36. How much it is? 138. 138.
Yes, sir.
138. Then what is the R1? R1 is equal to square root of 138. That is equal to 11.75 ohm. This is the ohm. Understood now this? Diploma students?
Yes, sir.
Yes, sir.
Practice like that they'll ask in the exam. Practice this problem.
Yes, sir.
Huh?
Yes, sir.
You have to practice this problem.
Yes, sir. Okay, sir.
Again. Okay na?
Okay, okay, sir.
Then close ಮಾಡಂತಲ್ಲ.
Sir?
ಕ್ಲೋಸ್ ಮಾಡ್ಲಾ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಲಾ? ಓಕೆ ಓಕೆ ಅಂತ ಇದ್ರೆ ಅರ್ಥ ಆಯ್ತಂತಲ್ಲ ಏನಂತ? ಅರ್ಥ ಆಯ್ತಾ? ಓಕೆ ಸರಿ, ಇನ್ನೊಂದು ಡೆರಿವೇಶನ್ಸ್ ಮಾಡ್ಬಿಡ್ತೀನಿ, ಆಮೇಲೆ ಇಲ್ಲಿ ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಅನದರ್ ಒನ್ ಈಸ್ practical parallel resonant circuit. Second derivation in the parallel resonant is practical parallel resonant circuit. Practical parallel resonant circuit. Resonant circuit. Okay, here it contains one resistance and then inductance, and again it is contains one capacitance, and it is connected a one voltage source. Okay, this is the voltage source. So here it is here IL, okay, and this is IC, and this is your RL, and this is the L, okay, and this is a C. Here admittance of that branch YL is given by 1 by RL plus JXL. This you can rationalize this term RL minus JXL divided by RL plus JXL into RL minus JXL. So this is nothing but RL minus JXL divided by, okay, this is RL square plus omega square L square. We did in the previous same. Okay. I'll write it only XL square only. I'll write next steps. I'll write this is RL square plus J square is minus 1 minus minus plus. Therefore, this becomes only XL square. Now, this is we can write it as RL minus okay, I'll write it in next step. This is where YL. Then what is a YC? YC is nothing but it contains only one. No, that's 1 by XC. That is 1 by J omega C. That is equal to J omega C only. Then what is the total admittance? Total admittance is given by YL plus YC. So this is nothing but RL minus JXL divided by RL square plus XL square. Okay. Plus YC is J omega C. Now separate real and imaginary part. This is RL divided by RL square plus XL square, okay, plus J into omega C minus XL divided by RL square plus XL square. Now separate real and imaginary part. We are separated, and then here for parallel resonance susceptance is 0. That is omega C minus XL, okay, divided by RL square plus XL square is equal to 0. So this is again rewrite, that is omega C, and XL is nothing but omega L divided by RL square plus XL is omega L, that is omega square L square, that is equal to 0. So because we are calculating resonance, therefore this you take as a omega naught C, omega naught, instead of omega labeled as a omega naught L divided by RL square plus omega naught square L square, L square is equal to 0. Okay. Then this is, you take the omega naught as a common factor here. Omega naught is then C minus L by RL square plus omega naught square L square, that is equal to 0. This we can write it as C minus L by RL square plus omega naught square L square is equal to 0. This also you can write it as a C is equal to L by RL square plus omega naught square L square. Further, so this cross multiply, then we'll get RL square plus omega naught square L square is equal to, you can write it as L by C. We want F naught, no, therefore retain omega naught square L square term, remaining term you transfer to right side. So then we want only the omega naught square, therefore this becomes LC into L square minus RL square divided by L square. That is nothing but 1 by LC minus RL square divided by minus 1 by LC minus RL square divided by L square. But this is nothing but omega naught is nothing but a 2 pi f naught whole square, that is equal to 1 by LC minus RL square divided by L square. So f naught is equal to 1 by 2 pi square root of 1 by LC minus RL square divided by L square. Suppose if RL is negligible, if RL is negligible, if it is RL is negligible, then we can write f naught is equal to 1 by 2 pi root LC. It's similar to same as a series resonance. You have to derive up to this f naught is equal to 1 by 2 pi square root of 1 by LC minus RL square by L square. Is it clear? Hello?
Yes,
Hello? Understood now?
Yes, sir.
Yes, sir.
Okay, this is another derivation in the parallel resonance circuit. And then you have to solve the problems in both series and resonance circuit and parallel resonance circuit.